Hey, welcome. Today we are talking properties of log functions. We are live during period 1, Hrs Algebra 2. We are mainly going to simplify, evaluate, solve expressions and equations using logarithms. Here are some big time properties, okay, for you guys to make sure that you know. I'm just going to go down through them briefly and give you an additional example here. But first off, you've got log base to the b is equal to 1. It's all based on what your exponent is. So I'm going to show you a different example where it's not necessarily 1, but I think you'll probably see that later on. The reason that your answer is here is if your base and your number that your log is going to are the same, your answer is going to be your exponent. So say, for instance, I had log base 3 of 3, and this is to the second power, my answer would be 2. It's all based on what that exponent is. As long as these two numbers are the same, everything will cancel out. Okay. A lot of that has to do with the changing that we did before from logarithm to exponential in it. So just to kind of preface, say for instance, I had that same exact result and I didn't necessarily know what the answer was going to be. I could change it into an exponential form. 3 to the question mark is equal to 3 squared. And as we saw from a previous lesson, these would cancel out, and my question mark would be 2. This is why this rule can occur. If you don't necessarily remember this rule, you can always use that change into an exponential in order to solve. The next thing is called the product property. If you have two numbers that are multiplying, or even one number that multiplies to give you two numbers, you can split it into two separate logs, and then vice versa. Here's a great example that I can give you. You've got the log base 2 of 15. If I needed to, I could actually split this into log base 2 of 3 times 5, which then would maximize itself out into log base 2 of 3 plus log base 2 of 5. So something to kind of think about. You can also work the other way in order to simplify. That's usually what you're going to do, is condense everything into one, but you can also expand as well. Quotient property is very, very similar. Again, say for instance I had those numbers. Let's do something like log base 5 of, I don't know, maybe let's go 7 over 3. I could set this up to be log base 5 of 7 minus log base 5 of 3. I then have the power property. Power property, give you an example with some numbers. It's essentially whatever your exponent is, your exponent will move to the front. So if I have, let's do log base 3 of 7 to the 7, let's go 7x to the 4th. I could now make this 4 log base 3 of 7x. And we'll get to it, and then you can split that up a little bit more if you need to, but I just at least wanted to give you that example. And then the last thing that we have here, exponential logarithm properties. It's almost identical to what I was talking to you about with the very first one. A log, any base and number of log that's the same, the exponent will be your answer. And then if you have a base and the exponent is a log with the same base, whatever that number is out front of the log will also be your answer as well. I'm going to show you an example of each of those inside of here too in your notes, so we won't have to really worry about copying those down. Those are probably the easiest to see. Questions at all? These are things that you'll have to memorize, or at least get familiar enough with that you can kind of work your way through. Let's go ahead and take a look at some of these examples. Starting with how to approximate the value. So if we have here, it says the log base 2 of 5 is approximately 2.3219. It says approximate the value of log base 2 of 5 divided by 2. So I think the first thing that we want to do if we're approximating and they give us the value is we want to split this into two different logs. So using our property where division is subtraction, we'll say the log base 2 of 5 minus log base 2 of 2. They've told us that log base 2 of 5 is 2.3219. We also know from our log bases, okay, and I'm going to scroll up for a second because I want you to see this. If we have the same base and the number, our answer in this case will simplify down to our exponent. Because this exponent is a 1, this will be minus 1. So our answer then will be 1.3219. I'll go over this one more time because I feel like it's something for some of you that might be out of the thinking outside the box. Okay. They give us that log base 2 of 5 is approximately this number. They give us log base 2 of 5 over 2. Because it's division, we can now split it into two separate logs using subtraction. And then from there, we know that log base 2 of 5 is at 2.3219. And log base 2 of 2, since they both have the same number, a 2 and a 2, okay, the base and the number to the log is the same. Our answer there would be our exponent, or it would simplify down to our exponent, so then we can subtract. Questions at all? Before we move to the next example. Okay. All right, let's take a look at example number 2. So we just what we called expanded. Now we're going to contract or condense into one single logarithm. So we're going to write this as one single logarithm, and then we'll simplify throughout. Two of the rules that we know is subtraction, whenever we're condensing, means division, and addition means multiplication. So we're going to do log base z of 2a over b plus log of zbc. Now, some of you might all be able to write that all out in one step with one log. I'm doing it in two separate steps so you can kind of see where I'm going with things. Now I've got multiplication, so I've got log base z, I'll write my z's that way, of 2ab times bc. And if you notice, this bc is in the numerator, our other b is in our denominator, so we can cancel those out. We'll end up with log base z of 2ac. The whole premise of writing this out is to literally write it with one logarithm, meaning log of, and then boom, there's your answer. Okay, you should only have one log when you're condensing. You shouldn't need any more than that. Questions at all? Keep moving through here. PEMDAS works whenever you're doing this as well. Go ahead and try this at your seats. Remember that if there's a number out front, it becomes an exponent, but try this one at your seats and see if you can get the same answer that I'm about to get. Give you a minute. All right, so I'll change to red here just to show you what happens. This 3 becomes my exponent. So now I have x cubed in my log. Parentheses come first, so I'm adding those two, which means I'm going to create multiplication. So it'll become 4x. And then the subtraction means division. I've got an x cubed on top, and I've got an x to the first on the bottom. So I'll cancel an x out, and I should have log base b of x squared over 4. All right, so let's talk a little bit about evaluating a couple different ways in order to evaluate. So some of the problems that we've done before, we were approximating the value in example 1. And then in example 2, for both of them, we were writing them as a single logarithm. For example 3 and the next few examples, we're just going to evaluate, which means we're going to simplify and try and get it into just one number. If you notice, there's no variables at all. There's a couple different ways to do this, and I'm going to show you a couple different variations so you can kind of have this down. The first thing is to use the one property that we talked about, where it was log base b of b to the x is equal to x. 27, if you can see that the number, like the base is 3, 27, if you can see that like that is 3 to something power, that's where this particular will be like perfect for. So if I rewrote this, I could rewrite this as log base 3 of 3 cubed to the 8th, which would then mean that these would cancel, and my answer would just be 3 times 8, which is 24. That's one way to do it. If you can see it that way and it makes sense to you, then by all means, yes, that works. If for some reason you forget this, though, okay, it happens. You guys have a lot on your minds. If you forget that, there is another way. This is a method that I've shown some of my regular students too, and it kind of works well. Say, for instance, I've got the same log base 3, 27 to the 8th. If you set it equal to x, you can change it to an exponential. You can say 3 to the x is equal to 27 to the 8th. And then you could use your same base property, where if you get the same base, then some numbers will cancel. So like, for instance, 3 to the x is equal to that 3 cubed times 8. So then x would equal 24. Either method works, as long as you can see that the number that you're dealing with, like 27, will go into that base. Okay. Example number 4, evaluate. This is something that will, like, once you see it one time, I'm pretty sure that you guys will get this pretty well. Using that same exact property and another one that we had talked about, if it's the same base in the same log, then you're canceling them out. So in this case, this will be 5. And then we also talked about if you have a base and its exponential is a log with the same base, those will cancel out. You'll be left with the log number. So your answer here is 13. All right, and then our last evaluating example, 2 log 12 base 12 6 plus log base 12 4. In order to evaluate this, we're going to want to condense it into one log. Makes it a little bit easier for us to do. You can do them separate if you need to, but I think with 6 and 4, it makes it a little more difficult, especially since it's 12. But again, our number out front becomes the exponent. So log base 12 of 6 squared. I'm just showing you, I'm the math teacher here, so I'm going to show you all the steps. Okay, this is then going to be addition means multiplication. So log base 12 of 36 times 4. Log base 12 of 144. And then if it was me, I would try and find 144. 12 to the what power gives me 144, so I could get an answer. If not, then I'll show you how to do it here in a second. So 12 squared, and then these are now the same, so my answer is 2. If you get to this point and you don't know exactly what you're doing, again, you have it all condensed into one log. You can set it to x and then say 12 to the x equals 144. And then hopefully you know what that one is. 12 to the x is equal to 12 squared. So x is equal to 2. Okay, it's using the same principle. The one on the left is actually just the shortcut. I personally don't feel like this is anything that's super challenging for you. I think the biggest challenging is remembering all the different little formulas that could go into it and all the different shortcuts. The very last thing that I see here is called the change of base formula. Okay, just give you a second. Excuse me for a minute. So whenever you're looking at this change of base, we've got a couple different things. We've talked about, for the most part, we talked about all of these first two in using converting. When you have a log on both sides, okay, and it has the same base, you can actually cancel those logs out. So you could take log from both sides. I'm looking at this third one here. Let me highlight it. Okay. If the logs are the same on both sides, then this can literally be written as b to the y is equal to m. Like you can solve each side. You could also then bring the power down if you wanted to and divide. It's totally up to you as to how you want to do that. If you notice here, it works both ways with the ln. And this is kind of how we get our change of base formula. So if we weren't going to solve and we were to take the exponent down, we could literally say that we have the same base on top and bottom using division. This is a really nice way to plug things in that don't have a base of 10 or a base of e into your calculator as well. And it's also kind of a nice way to change and do simplify problems that you might not quite know how to simplify. So let's go ahead and we're going to take a look at this last example using change of base. It says evaluate log base 7 to the 14. Hey, 7 to the what power gives us 14? There's not, it doesn't hit my head as to what is going on. I know that 7 times 2 is 14, but it doesn't really make a whole lot of sense for us. So what we can do in this case is we could convert it into a couple different things that we need to find. Log base, let's see here, 7, let's see, 28 over 2. Log base 28 to 7th minus log base to 7 to 2. I'm still not seeing how this could be solved. One of the ways that we could do this, though, is we could just plug it into our calculator. And instead of doing it this way, we'll essentially just write it as log of 14 divided by log of 7 based on change of base. So we could try and get fancy and try and do all these different things to try and simplify. But in the end result, I think your easiest bet, because it's a 7 and it's a 14 and nothing's quite going to make sense with us simplifying, is to do log base 14 over log of 7. This automatically makes this a base of 10. So then we can plug that into our calculator to solve. So log 14 parenthesis divided by log of 7, parenthesis, hit enter, and you'll get approximately 1 point, let's see here, 1.3562. Something like this would be calculator section. And again, this is one of those things where if you're struggling like I was at the very beginning and you're like, well, 14, maybe I can make that 28 over 2 and then split it, and it still isn't quite happening for you, that's where you can automatically use that change of base formula.